showing it, they're actually showing this analog multiplexer as part of this whole thing, and it actually is not.
Okay.
And there's a thing called a sample and hold, and what a sample and hold is, an ADD converter cannot do the conversion unless the signal is not moving. So it's like me trying to draw a picture of you, but if you're moving around, it's hard for me to draw it, right? Well, the same thing is true with this thing. What it does is, this thing right here takes a snapshot of the voltage. It stores it on this thing. That's why it's called a sample and hold. So when it's sampling, it's like the lens or the, what do they call it? The thing on the camera. It's like the
Flash?
No, not the flash. You know, the camera actually has the shutter. The shutter
Right.
will open, and when the shutter opens, the film is actually exposed to the scene out there, right? Well, when this thing is doing a sample, it's like the shutter is open. Okay, so it's looking at all the voltages bouncing around, whatever. Then when it does a hold, the shutter is closed, and when it closes, whatever the voltage was in that moment is going to stay that voltage. Okay, and so the moment that happens, this thing can then start doing the conversion.
Okay.
So the way you can look at it is, if you imagine you got a voltage that's changing, when it's doing the sample. When it's doing the sample, the voltage changes. So this is sample. And then when you tell it to hold, the voltage is going to stay wherever it is at that moment in time when you tell it to hold. So that's why I call it a hold, because then they'll say, okay, the voltage was 1.38976, and it will lock there and not change. And in that moment, it then starts the conversion, converting that to a digital word. Okay, and that's what this right here is. And again, that's actually a separate system, but it's actually, they're drawing it as part of the ADD converter, and it actually is.
So, like, we don't need any wires going into the sample and hold.
All that stuff is built in the chip.
Okay, so if it's in here, if it's in this, then it's going into the AD or the AD. Like, the wires are in there.
That's right.
Okay.
In other words, this line right here is this is the micro P.
Okay.
So all this stuff, or so I guess I should say micro C, microcontroller. Everything from this point over is inside the chip, so you don't need to do anything.
So don't we have to find which port that the certain thing is at?
Yeah. In fact, you can tell. See, the thing is AN7. If you look at the data sheet, and I just printed them out. I don't know if you want me to staple this or not, but this is.
Yeah, you can.
Yeah, let's see, can we find it? See right here, AN6. If we go back to, okay, AN7. Okay, if you look at this chip, where is it? AN06. That's this pin right here.
Okay.
Okay, AN543210. Those are these pins.
So, but where's the pins for the analog and digital part?
Well, that's what I'm saying. All this stuff is on the inside.
Okay.
See, what I'm saying to you is that these inputs are the inputs to the analog multiplexer. Okay. And then the analog multiplexer is going through the sample and hold, which is then attached to the ADD converter.
Okay.
And so all that stuff is internal. So all this right here is going to be manipulated using software, not with wires.
Okay. All right.
Okay.
Okay.
And so, and then you have, see, there's the analog voltage. See, VDDA.
Yeah.
And then they probably have analog ground over here somewhere too. The digital ground. There's an analog ground right here. So they're showing you all these different things. And then, you're going to actually have to find this stuff on the board. If you look at the board, because you're not going to be able to touch these things directly. There'll be ports on the board, and those ports are tied to these different inputs.
Okay. Can we start, show me how to do this schematic?
Yeah. Okay. I can do that. I guess I'm trying to figure out what's the best way to do the low-pass filter.
And you were saying that we can get an amplifier that has 4 amplifiers in one.
Yeah, let's look that up. Let's look up this 7. You want this thing too?
Yeah, that's
Okay.
that's important. That page.
I see that they're showing you that this is ATD 0. That's really weird. And they talking about read write, but you know, if you think about it, when you're reading from an ADD converter, you can't really write to it. You can only read from it. See, sample and hold stage accepts analog signal from an input multiplexer and stores them as charge. Okay, and so that's telling you how it operates. You probably want to read it, right, because it's telling you all the details. And here's some example code, which will probably be useful too. And right here's some of the conversion time. The conversion time for 10 bits, when the clock frequency is 2 megahertz. The conversion time for 8 bits when the clock. I don't know what the frequency is for the boards. You probably need to go and check that. Although it doesn't really matter because you're not looking at super high speed stuff anyway. So for what you're doing, you don't need really high speed.
Okay.
So a person's temperature is not going up and down rapidly, right? It's just, you know, they sit down, the temperature will rise, and that's it.
So on this circuit, what we thought was we pinch this thermistor, and then you see the temperature change. Is that good enough? Is that efficient?
That's sufficient for what you're trying to do, because what you're trying to do is you're measuring 2 different temperatures, right? And you're going to set a threshold for the point where you say there's somebody sitting there. In other words, the temperature difference between the ambient temperature and the temperature where the person is seated, if the difference is, for example, 10 degrees, your software might decide in that moment that there's a person sitting there. You see what I'm saying? Because all you're doing is saying, okay, if the difference between these two is this number, there's a person there. If it's not this number, then there's not a person there. Okay. The reason why it's important to set a threshold is because of one of the problems I mentioned before. I mean, imagine, I'm sure you've seen this happen, like if you go to one of the benches downstairs, if the sun is glaring through a window in a certain area, you know that area can get really hot. That one area is really hot, and another area that you're measuring the ambient temperature in may not be so hot.
Yeah.
And so there's a temperature difference, but it's not because of a person. It's because the sun is hitting this area. And so you got to build in your software and make it smart enough where it'll know, okay, that's just the sun.
Okay.
Okay. And so the way you can do that is put a threshold. If the difference is only 10 degrees, that's not a person. If it's only 12 degrees, it's not a person. If it's 20 degrees, it's a person. That's what I'm saying. You're going to have to go out and figure out what that difference is, what is a person and what's not a person. Okay. I can't believe you're using an ATD thing. Huh? Weird. Anyway. Okay, you wanted to get in here. I'm still trying to decide what's the best way to do your filter. Let me look at some filters. I actually have some books, I think, on filters, but let's see what we can find. That was quick. Filter design. Here's a design right here. I like that. That one's pretty good. I guess we can put together the mathematics to show what it is. We can use this structure for a low-pass filter.
Okay. Can you print from this?
No, but we can do
Okay.
it from here.
Right.
Yeah. And let me bring all this stuff down. In fact, all we need to do is go to another window. There we go.
And I have to keep saving this like every time.
Yeah, you
Okay.
should. You know, that's one of the weird things about Linux. It can do bad stuff. Okay. Let's see. So you got that. See.
What you hit to pull that up?
Oh, good question.
L?
L.
Okay.
Okay.